So module 4, data visualization. Visualization is a very integral part of data science. It helps in communicating a pattern or a relationship that cannot be seen by looking at the raw data. So you can do a Python notebook in various forms. Without installing, you can do it like you can use Google's Colab. So you can access Google's Colab using this link. And then you can use click new notebook. Another way of using Python notebook is use Anaconda Navigator. For this, you have to install Anaconda Navigator. You can search Anaconda Navigator and install it. So once you open Google Colab, you will get a page like this. So you can click here, a new notebook. You can click here. Then you will go to the new notebook. A new untitled notebook with the extension .ipynb will be displayed in the new tab of the browser. So it will be looking like this. This will be the screen. And you can note that a new untitled 3 will be opened. You can either click here and type a new title for this notebook. Then you can just type. There will be cells here. These rectangular shaped elements are called cells. You can type your commands here. So suppose you want to print hello matplotlib. You can print it here, this cell. So after printing this one, you can save it. So what is matplotlib? It is a powerful plotting library useful with Python and NumPy. It is a cross-platform library for making 2D plots. So if you want to install matplotlib, its dependency packages will also be installed. It is available in the form of wheel packages on the standard Python package. Can be installed on Windows as well as Linux. You can use the command pip. Pip is a package manager, so you can install using pip. Matplotlib do not fall under Python standard library, hence any other third-party libraries needs to be installed before it can be used. So in order to check the version of the matplotlib, you can use this command matplotlib version. So you will get a string like this. So this is the version of the matplotlib. So pyplot is a module in the matplotlib package. This module provides an interface that allows to implicitly and automatically create figures and axes to achieve the desired plot. So how to import the matplotlib? So suppose you are defining two elements x and y. So x is a vector. So x vector is denoted using square brackets and each elements are separated using commas. So here we are defining two elements x and y. X with elements 5, 2, 9, 4, 7 and y with elements 10, 5, 8, 4, 2. So you can import matplotlib using this command. Here we are using plt dot plot xy means PLT is an object of matplotlib.pyplot. So PLT, you can either use PLT plot dot plot PLT dot plot xy. Otherwise, you can use matplotlib.pyplot dot plot xy. Either use this one or use this one dot plot. Okay. So you will get a diagram like this. You will get a diagram like this. X and Y will be plotted here. So next method. Okay, here we are using matplotlib.pyplot.plot of x, y. Here we didn't mention the object of matplotlib. So full code for plotting a line. So first you have to import matplotlib. So from matplotlib import pyplot as PLT. So you have, then we need to give the x values and y values. After that, function to plot, that is PLT dot plot of xy. Then you have to show the plot. For that you can use PLT show. This is a full code to plot a line. So this is about a Python code, not our code. Okay, in the previous code we had used plot xy. Before that you have to use the object. PLT was the object. Okay, don't forget it. Otherwise you have to mention matplotlib.pyplot. Okay, this will plot a line. So here we are using two arguments x and y. And you can use x label and y label. It is used to labeling the x-axis and y-axis. X label is for x-axis, this is for x-axis, and this is for y-axis. Then you can use legend. Legend will be displayed here. If you are having two graphs, this is about orange ball and this is about blue ball. Then blue and orange will be displayed here. Okay. Previously we had discussed about what is legend. Then controlling the properties of the line. So for plotting the line, after you can use directly like this also. Instead of x and y, you can directly give the values of x and y within square bracket. Don't forget to use the comma here. This comma. Don't forget this comma. After that, you can use plot.show. Now using some keyword arguments. Here we use two libraries, pandas and numpy. So NP is the object of numpy, PD is the object of pandas. So in order to use plot function, so here we are using some line attributes. Here we are using line width equal to 4. So after that, we will get a thicker line. Okay. Then next is using setter method. Here we set line dot set dot set. Line style is dot. So look here, the line will be displayed like this, dotted dashes. After that, you have to use plot show. Then next is using setp command. It prints a list of properties you can set for matplotlib object. So example, so here in this setp option, we are using the line color as R. So we got a red line and line width is 2. So this is another way of setting color and width for a particular line. So this command we had already discussed earlier. So these are some colors and markers, line styles of plotting line using Python. Okay, now creating multiple plots. Multiple plots can be created in a single window. For creating points, we can use this command p1 nb.arrange. So in the p1, we have certain set of points. After that, we are plotting the sine wave of those points using this equation. So check it. Actually, we are dividing this whole window as two rows and one column. Okay. So we are using subplot for plotting each and every subgraphs. So in the first, this means subplot 2, 1, 1. This means 2 is the row and 1 is the column. So here we are having 2 columns and 2 rows. So in the first row, that is 1. This is first one is 8. This one is row and this one is column. In the first row, in the first column, in the first row and first column, this plotting the sine wave using blue dashes. So blue dashes, we are plotting the sine wave. And in the second line, in the second plot means we are dividing it into 2, and in the first and second, we are plotting the next one, that is this plot. So here we are plotting the cos function and the plotted using R dashes. Bar graph. Bar graph is used to make comparison between different categories or groups. So in the previous we had used PLT dot plot for plotting lines. Instead of plot, we are using bar. Instead of this plot, use bar for plotting bar chart. So what is x and y? X and y are the vectors. So one example. So here we are using average mark as this one is one vector, this one is another vector. Average mark and physics. So we are plotting average mark PLT dot bar. These one are the width of the graph. 0.25, 0.125 to 2.25 are the interval between the graph. Okay, then first we can print average mark. This one is average mark. Then label of that bar graph is average. Here we will print average and its label will be average. And width of this bar is 0.5. Okay, next one we are plotting physics. So physics will be printed here like this bar and label is physics and color of physics is red. Instead of in order to distinguish this physics and average, we are plotting this bar chart of physics in red and width is 0.5. So legend is plotted and the x label is range. X label means the label of x axis. So here this one is range and y label is mark. Here y label is mark and title is means the whole title of this one is comparison. And we can plot it using plot.show.
So how to add text to the bar chart? So we are creating a random sample nc.random sample file. So we are arranging this bar. Means np arrange file means it will return an array with 5 elements. So plot bar chart will plot the bar chart with X label as indices and Y label as values. So now we will add a text at the location 1.7. The text is string is this one, new equal to, and it is followed by NP mean of n. So it is the mean of n. So it will be printed here. And after that you can use plot show. This will give this chart. Another option is you can use text command to add text within plot. So first parameter is x-axis value and second parameter takes y-axis value. And the third parameter is the text. So LaTeX expression can also be used. Next option is using annotate command. It will take the text and the position of the section of plot and the position of text. So we will use a subplot, then use arrange an array, then use a cos function to create a cos function is created and it is stored in S, and we are plotting S and use an annotate. So here we are using local max and arrow position is like this. So it will be face color is black and string equal to 0.01. So then y limit is defined like this and we will plot it. So we need to plot it side by side. So with parameters 1, 1. That means one row and one column and plot is 1. So we will use np.arrange, start, stop and step. This is the syntax of np.arrange. So syntax of annotate is like this. Text, then xy, x coordinate, xy text equal to arrow pop equal to. So an example will be like this. So you can add the x limit also. So display text will display whatever be the within double quotes. X location and Y location gives the coordinates of the data points. X text and Y text means the text appearing using the coordinate. X coordinate is the sets the coordinate system and text coordinate means it is the where the text is to be placed. So this will be the graph. For styling your plots, you can use plot ggplots. And these are the points to be plotted. So we can use 538 style. So for that you have to use 538. Sometimes you want to specify a block of code to a particular slide. So you can use width for using a block of code, that is dark background.
Box plot. It's plot to understand the spread, median, and the outliers of data. Okay, this is an example for a box plot. So here we have certain parameters. Q3, it is this one, Q3, Q1, and we will having maximum value, minimum value, and median. So 5 quantities: max, Q3, median, Q1 and mean. So we will discuss what's about these parameters. So any value that is greater than max or less than min is called whisker, is called outlier. So what do you mean by an outlier? It may be something like noise. So anything which is outside this maxima or minima is called outlier. So what is Q3? Q3 means this is this 75 percentile value of the data. It is called upper hinge. And what do you mean by Q1? It is called the lower hinge value. That is 25th percentile value of the data. And what is box? Box means it is the difference between upper hinge and lower hinge. What is upper hinge? Upper hinge means Q3. Q3 minus Q1 is box. So then median. Median represents the middle value, midpoint of the data. And max equal is the upper inner fence and min is the lower inner fence. So max equal to 1 point times above Q3 and min equal to 1 point times below Q1. Okay, this is an example code. So we are going to plot some data. So before that, we need to create some data. So np dot random dot seed10 means we are creating some random elements. So some random data are selected, created here. And after that, we are going to plot it. So these values are plotted here. So first we need to create. So now we need to plot the data. The BP variable in the box plot. What is BP variable? BP equal to we had plot the box plot. So it is a Python dictionary with key values, boxes, whiskers, outliers, caps and median. So the values in the key represent the different components of the box plot and their properties. So in order to add fill color, you have to use patch artist equal to true. And to change outline color, fill color and line width of the box. To change the outline color, you have to use box.set equal to color. This is the color code of a particular color. Line width equal to 2. To change the fill color, we can use box set equal of face color equal to this one specifies color code. Okay, so for each box in BP of boxes, so there will be a number of boxes in box plot. So for each plot, we are changing the outline color and fill color. Okay, to change the whisker color, you might remember what is whisker. So for each whisker in the BP, the color is set as this one and line width equal to 2. So in order to change the color and line width of cap, for each cap in box plot, color is this one and line width equal to 2. And changing the color and line width of median. So for changing the median, for each median in the box plot, set the color and line width. And to change the style of outliers and their fill. So set like this for each outlier, flyer dot set equal to marker equal to 0. That means we are using 0 as the marker, O as the marker. And color is this one, and alpha denotes the transparency. So finally you will get like this. So this is the whisker. So each box plot is having an outline color. This is outline. And this one is fill color. And this yellow specifies the median. Okay, this is the outlier. So here we are having 3 boxes in the box plot. So next one is heat map. A heat map is a graphical representation where individual values of the matrix are represented as colors. So it is a matrix where individual values are represented as colors. So it is useful in visualizing the concentration of values between 2 dimensions of matrix. So it is used in finding patterns. So for example, create a basic heat map of a 10 by 6 matrix of random values and visualize it. So code will be like this. We are creating a random value using NP, where NP is the object of NumPy. Rows equal to list. So this is the list of some values by label, and column equal to list of A, B, C, D, Y. So after that, so basic heat map plot is plotted using this command, plot.pcolor of data. So p color is used to create the heat map colors. And similar to the previous code, you have to show the graph. For that you can use plot.show. Okay, how to add column or row labels. So in the previous slide, we had already initialized the values of columns and rows with some strings, some characters. Columns like Q, R, T, S, and rows like A, B, C, D, E, F. Okay, we can plot a heat map using this function, plt.pcolor of data. So in order to show the labels, X ticks. So we are arranging the X ticks at some position, np.arrange 0, 6, because there are 6 elements here. A, B, C, D, E, F, 6 elements, 0 to 6. So 6 elements. How it is arranged? It is arranged as 0.5. 0.5 is incremented position of the X ticks. This one denotes the position of X tick. And column specifies the label. Similarly, Y ticks, that is Y label here, this one. There are 10 labels. So this is the position of Y tick, and this one specifies the label. After that, you can use plot.show to print the box plot, heat map. Okay, how to change the color map? Suppose you want to visualize how much is concentrated or participated in a particular job. For example, so suppose you are using a red color map, then you can show that if it is a light red, then you can specify some 10% is participating. If it is little bit darker, then you can say that 20% is participating. Like that, if the color shade becomes darker and darker, we can say that it is a little more participating. So here, for that, you can use PLT color, P color data. This is same as previous case. Now you have to change the color map This is plot. CMB denotes color map. Red color map is used here and edge color is K. So these three commands are same as previous slide. So generate some test data. So sometimes a huge number of values are to be plotted. So use in that case bin the value first, then use the code. So first of all, you have to generate two values x and y with some random seed. Here NP is the, what is NP? Is a object of NumPy, and we are creating some test data randomly. After that, we are creating a 2D histogram of the random data x and y. Here we are having huge data. So, and we are selecting bins, number of bins as 50. So the output will be heat map, x edge and y edge. So extent is denoted as x edge 0, x edge -1, y edge 0 and y edge -1. So plot I am show. Here heat map is already there and extent is already there. So I am show will produce this graph. So then next one is scatter plot with histogram. We can combine a simple scatter plot with histogram for each of the axes. These plots help us to see the distribution of values of each axis. To generate some randomly distributed data for two axes. So we are generating two randomly distributed data and it is stored in x and y. So another thing is null formatter object is created, which can be used for eliminating the x and y labels of the histogram. So this one is the null formatter object created. Null FMT is the null formatter object. In order to plot the scatter and histogram plots, we need to define the size, height and width of the scatter and histogram plot. In the first case, we are defining left and width. Left and width is 0.5 and 0.65. In bottom and height is defined as 0.1 and 0.65. Then bottom height is equal to left height equal to left plus width plus 0.02. Then we will be defining the size of the scatter and histogram plots using the following code. Here left, bottom, width and heights are represented. Once the size and height are defined, the axes are plotted for the scatter plot as well as the histogram. Okay, first of all, you have to start with a figure. Plot figure 1. So we are plotting the first figure. 1 means we are plotting the first figure. So what is the size of that figure? This is the size. Figure size equal to 8. Then we have to set the axis of scatter plot. This one specifies the axis of scatter plot and these two specifies the axis of histogram. So we are having two histograms x and y. So histograms x and y axis labels are eliminated by using set major format, null formatter. Previous we had defined what is null formatter. So null formatter is defined by NULL FMT. So we are setting the x-axis and y-axis label as null formatter. So we are eliminating the x-axis label and y-axis label. So now we are adding the scatter plot using this equation. Remember that there is a function dot scatter. We need two parameters x and y. The limits of x and y axis are computed using the following code. Here, maximum of x and y values are taken. So, the maximum value is, so here maximum of x and y is taken and the maximum value is then divided by bin, then 1 is added to it before it is again multiplied with the bin. So that is int x y max divided by bin plus 1 into bin width. This is the limit. So the limit value is calculated is assigned to the set xlim method of the ax scatter. So ax scatter dot set x limit equal to minus limit or to plus limit, and similarly you have to set y limit. The bin variables creates a list of interval values which can be used with the histogram. So it is used like this. Bin is used using this command. Here np is the numpy object, and you have to arrange the bins. Bins means the number of bins. This one, number of bins. How many bins are created in the histogram? So how will you arrange it? From minus infinity to plus infinity plus bin width to bin width. That is how you are arranging the bins, position of the bins. So histograms are plotted and the one that is horizontally set after orientation parameter. So we are having two histograms. First histogram is horizontal one and the second one is vertical. So first histogram is plotted using this equation ax histogram x dot hist. So we are plotting histogram using dot hist. And the first parameter we are using horizontal histogram. So here bins equal to bins. And next one is, sorry, first one we are setting the vertical. This one specifies the vertical histogram and this one is the horizontal. If it is horizontal, you have to specify the orientation. The limit value of the scatter plot is fetched and then assigned to the limit methods of the histogram. For example, so here ax histogram x, this is the histogram name, dot set x limit. So x limit is what? It is ax. We need to set the scatter plot limit as the limit of histogram. So here the parameter is ax scatter dot get x limit. So we will get the same x limit as in the scatter plot. After that you can plot it. So you will be getting like this. One is horizontal histogram and the other one is vertical histogram. So this one is another visualization technique. So scatter plot matrix. Scatter plot matrix can be formed of a collection of variables where each of the variable can be plotted against each other. So the following format code generates a data frame DF which consists of 4 columns with normally distributed random values and column names named from A to D. So in the columns, so we are having 4 columns with normally distributed random values. So content of the columns will be normally random values and the column names are from A to D. So how will you create a data frame? So this is the command to create a data frame. So this one is the data. So we are creating random data. So it is a numpy object np dot random. So we need a 1000 element, matrix with 1000 elements, 1000 rows and 4 columns. And what is the column name? Column name is ABCD. Okay. So after that, we need to plot we need a scatter matrix plot. In order to plot scatter matrix, you have to use PD tools. This one. This is the data frame. DF is the data frame. This one denotes the transparency. This is the orientation. This is diagonal is the histogram, and this one is the figure size. Okay. So finally you will get like this. The scatter matrix helps in plotting. It takes data frame object and the required parameters. The diagonal graph is defined as a histogram, which means that in the section of the plot matrix where the variable is against itself, a histogram is plotted. So it is a important question. What is a diagonal graph? So instead of a diagonal, we can also use kernel density estimation for the diagonal. So scatter matrix is plotted using like this. This is the data frame. Then we need transparency, then figure size, and this is the how you are plotting it. Okay, what is kernel density estimation? It is a non-parametric way of estimating the probability density function. So this is the kernel density estimation. So it will helps in understanding whether the data is normally distributed and the side towards which it is skewed. Next is area plot. It is useful for comparing the values of different factors across a range. So area plot can be stacked in nature where areas of different factors are stacked on top of each other. So this is an area plot. You can see the area plots are first area plot, and after the first area plot is blue, second area plot is orange, then pale yellow, then green. So first you have to mention the data frame. This is data frame. PD dot data frame. Data frame is created randomly. So how many rows? 10 rows and 4 columns with the column names PQRS. So this data frame is plotted. This is the equation for area plot. Not equation, command, syntax of the command. So DF specifies the data frame. So data frame dot plot equal to, what is the kind of that plot? It is area plot. To remove the stack of area plot, here the area plot is not stacked as seen previously. So you have to use stacked equal to false. The other command is C. Next one is bubble chart. So bubble chart is basically a scatter plot with an additional dimension. So bubble chart means a scatter plot with additional dimension. The additional dimension helps in setting the size of the bubble, which means that greater the size of the bubble, the larger the value that represents the bubble. So it will be helpful in analyzing 3D data. So for the following example, create a sample data of 3 variables and this data is fed to plot method.
Okay, how to set the command? So here plot style dot use ggplot. So style of plot is ggplot. That is point by point are plotted. Okay, then you have to define a data frame. So as previously defined, PD means pandas. PD is the object of pandas. PD dot data frame equal to we are creating a data frame. This one is data frame. So NB randomly created database. Data frame. So it contains 50 rows and 3 columns. So we are having 3 columns. So we need to name 3 columns as A, B, C. And here we are using the plot equal to scatter. So this one is the X label and this is the Y label. Okay, this one is the S specifies the data frame with the last column C. Next one is hexagon bin plot. A hexagon bin plot can be created using data frame dot plot function and kind equal to hex bin. So previously kind equal to scatter. So hexagon bin plots are created using kind equal to hex bin. This kind of plot is useful when scatter plot is too dense to interpret. It helps in binning the spatial area of the chart and the intensity of the color that a hexagon can be interpreted as points being concentrated more in this area. So how the points are concentrated, that is what this plot will visualize. So first of all, we have to create a data frame. This is to create a data frame. Since it contains 1000 rows and 2 columns. The columns are named as A and B. Then the data frame is defined df of B and it is arranged. How it is arranged? 1000 elements are there. So you are arranging this one. Then plot, that is B, the column is arranged. Bth column is arranged. Data frame B is taken. So there will be 1000 objects in the B. So it will be arranged in a particular format. So it is plotted using a hex bin and X label equal to A. X label equal to A and Y label equal to B. And here grid size is defined as 25. Next is Turles plot. It is a layout of smaller chart in a grid with consistent scales. A smaller chart represents an item in the category called conditions. The data are displayed is conditional for the items in the category. So it will be helpful for finding patterns and structures. It is similar to garden Turles. That's why it is named as Turles plot. So this one is the example. So first we are creating a pandas object PD dot read CSV means we are reading CSV file. Usually this CSV file will look like a Excel file. We can open CSV file through Excel sheet. Then after that we are plotting. So tips.data will contain the data. Then we are plotting a figure, plot.fig. Then we are plotting this data, tips data. It is the total bill, X is the total bill and Y is the tip. So here we are plotting the total bill and tip. So plot.r, R plot. So Turles plot is plot. Syntax of Turles plot is R plot dot R plot. So R plot dot Turles grid sex smoker. So first one is sex smoker. Okay. So we are adding this, we are taking into consideration these two parameters, sex and smoker. So then we are adding R plot equal to geometric histogram. So we are using geometric histogram. Then plot render plot GCF. So this is how Turley's plotter is plotting. So rplot takes the tips data and x and y axis values are defined. Then Turley's grid are defined using smoker and sex. Then we use geometric histogram to plot the Okay, to change the Turley's plot to a kernel density estimate, you have to replace rplot dot geometric histogram as rplot geometric density. So in order to change Turley's plot to a kernel density estimate, you have to change this command. Previously it was rplot dot GOM histogram. Now it is GOM density. So you will be getting like this. So after that, suppose you want to draw a polyfit line together with this scatter plot. So here we are using rplot dot GEOM scatter. After that, you have to use rplot GEOM polyfit degree equal to 2. So here we are using polyfit line with the degree 2. The only difference is that geometric scatter and geometric polyfit are used to fit line on the plot. The scatter plot can be combined with 2D kernel density plot. So we will be getting like this. A 3D plot of a surface. To plot a 3D where sine function is plotted against a sum of the square values of the two axes. So here we have to use this kit and it is defined in axis 3D. So first you have to plot the figure. Then you have to define the axis. Then x values, how the x values and y values are arranged, the location. So how the grid is created. So now we defined R and Z. R is defined as a square root of x square plus y square and Z is defined as sine of R. So we can plot the 3D. So 3D plot means we are having three arguments x, x, y, z. So R strid equal to 1 and C strid equal to, that means row strid, and this one is column strid. And so we are using, this one is the color map equal to 4. So you will get like this. This is the color map. Color map equal to 4 means you will look like this. Here we are defining x-axis and y-axis with the ranging values -4 to 4. And we create a coordinate matrix with mesh grid, then squared the values of x and y and finally summed them up. And it is fed to plot function. So R strid and C strid parameters helps in sizing the cells on the surface. So we will be viewing using view int. So following is a code to view at 0 degree elevation and 0 degree angle. So we are creating a figure and the axis is defined for this particular figure and view in it is defined with elevation equal to 0 and angle equal to 0. Then we are plotting the surface with x, y, z and R stud equal to 1. C stud means that is column width. T map equal to hot. Hot map is, color map used is hot. So in order to view it in 50 degree, elevation equal to 50. The other code are same. So it will be look like this. So elevation equal to 50 and angle equal to 30. So you have to rewrite like this. So you will get like this. So that's about the different visualization techniques. So it will be an essay. So you have to write all those things, scatter plot. What are the plots you had studied? Scatter plot, histogram, then everything. Okay, please note that one. It is an essay question. Okay, now we are going to the second part of this module. So we are performing prediction with a linear regression. So linear regression means it is a study of linear additive relationship between variables. So it is used to create models in industries such as the factors affecting the sales of a product, price, promotion, or seasonal factors. A linear regression helps in understanding the influence of each of these factors on the sale of a particular product, as well as to calculate the baseline sale, which is basically the number of sales of this product in the event that there are no external factors such as price, promotions, and so on. For example, suppose in a retail industry, there may be certain factors like sales of the product, price, promotion, etc. So, how they are related? How the sales of a product is progress based on price, based on seasonal factor. That is defined by this linear regression. So, sale of a product can be predicted using the seasonal factors or price. A simple linear regression can be defined like this: y equal to a plus bx, where y is the dependent variable and x is the independent variable and a is the intercept and b is the coefficient. So, we already know this equation. So suppose a dataset consists of height and weight of a sample of men. So we are going to create a scatter plot based on this distribution. So first we are importing NumPy object as NP, PD object, panda subject as PD, and we are importing a stats subpackage from SciPy. Then matplotlib.pyplot as PLT object. So next we are reading a CSV file. It is located in the directory data and the file name is, this one is the file name. Okay. So first we need to plot the figure. And this figure is plotted in the first subplot. So what is to be plotted? We need the scatter plot of height and weight. So AX dot scatter, figure is AX. We are plotting in the variable AX. So AX dot scatter of S1 data. This is the data. So data of height. Data of height means this is the height. This is the weight. So we are plotting the parameters height and weight. So scatter plot of height and weight is plotted and label is assigned as height, X label and Y label is assigned as height and weight, and we need to plot the show. So we will be getting like this. So there is a linear relationship between the weight and height of the individual. So we will be getting a straight line. So in order to show the relationship, we can use this. So our data is located in the variable s1 underscore data. So dot correlation means we will get how the variables are correlated to each other. So we are getting two parameters, height and weight. So how the height and weight, height is associated with weight, it is 0.94, height versus height, it is 1. Like that we have to continue. So height and weight are clearly correlated to each other, and it is based on a correlation value, namely Pearson correlation coefficient. The Pearson coefficient is 0.94. Actually, the Pearson correlation coefficient ranges from -1 to +1. So if it is more positive means there is a strong relation between two variables. And if it is negative means there is less relation. But it is in the opposite direction. So how to generate a linear regression model with the weight as the dependent variable and x as the independent variable? So create a linear regression object. Linear regression object is created using this equation. So this line, LM. So LM is the object. So we need to fit. What are the data here? Height and weight. So first of all, we need to train the model using the training set. This is a training set. We are having two attributes, height and weight. So we are using some data as training set, height and weight. So we are fitting that one. This LM means it is a regression, and regression model is created. And LM dot fit means we are training it using some pair. These are the pairs we are selecting. Then after that, print the intercept value and coefficient value. So we will be getting the features and estimated coefficients. So features and estimated coefficient will be like this. So how to plot the scatter plot? Again with a trend line. So here we are using the subplot and plot the scatter. For scatter we need two arguments. S1 data is our data. So dot height means it will extract height values. S1 underscore data dot weight means it will extract weight parameters. So we will plot height versus. So what is to be predicted? Now our aim is to predict. What do you mean by prediction? So in the first step we had build a linear regression model. So after build a linear regression model means we have a model. That means we used some training pairs, and we will get some output. And this is the model. This is the model created. Now, in the second step, we are going to assign some test cases to the model. And based on the test cases, if the output of the model is correct, then the model is good. Otherwise, the model is not trained properly. So we need to train it more properly. So now we are going to predict it. So LM predict is used to predict the data. So we need the remaining data as test data. And here we are using red color for plotting that particular line. Then X label is set as height and Y label is set as weight. So plot the line. So you will be getting like this. So a red line is plotted. That is the predicted line. So multiple regression. Multiple regression occurs when more than one independent variable. X is the independent variable. So there will be more than one independent variable means there will be x1, x2, etc. xn. So depending upon these x1, x2, etc. xn, we are predicting the variable y dash. So y is the dependent variable and a is the intercept. b1, b2, etc. bn are the coefficients. So squaring the dependent variable means it is still linear. But if coefficient is squared, then it becomes non-linear. Okay, to predict the average points scored per game, the column descriptions are height, weight, success field goal. This refers to the percentage of successful field goals. Success free throws. This refers to the total percentage of the successful free throws. And the average point scored. This refers to the average points scored per game. So we have read the data which is located as data directory and the name of data file is basketball.csv. So it is stored in a data frame. Then you can use describe method to get the univariate metrics on each of the fields. So the output will be like this. You have 5 columns: height, weight, success field goal, success free throws, average point scores, and you will get count, mean, standard, min, 50%, 25%, 75%, and maximum value of height, weight, etc. And the correlation value between variables. So our data will be stored in B data. So B data dot correlation. So it will produce, the output will be like this. So height and height correlation is 1. Height and weight correlation is 0.834324. From the preceding table, we can see the following. There is a high correlation between height and weight. And there is a weak positive correlation between successive field goals in terms of height and weight. So average point seems to have maximum correlation with success field goal. The distribution of these independent variables with respect to dependent variable can be obtained using scatter plot. So we had discussed this scatter plot earlier. So we can plot between height and average point scored. So you will be getting a plot like this. So from this plot, it is clear that there is no clear pattern between average points scored per game and the height, because the distribution is random. So distribution between average point score and weight. So we are using weight and average point as parameter. The output will be like this. Is there any correlation? So 105 found seems like an outlier, also has a relatively lower average point score. We can also see that the players almost 240 found have maximum variation. So next we are going to plot the distribution between successful field goal and average point scored. So you will be getting plot like this. Okay, successful field goal has some linear relationship between average point because the distribution is scattered. We will be getting a plot like this. Training and testing a model of multiple regression. So for this we need sklearn and we need some functions from sklearn, linear model, cross validation, feature selection and preprocessing. From the statistical stats model we need SM. We are importing this as SM. So from this one, we need M.Sc, add constant and mean squared error. So we are copying data values into X. So from the X, so we have the data values as X. So we need to split the data set into training set and test set. It is based on cross validation. That is cross validation. We are splitting it into training set and test set. Okay, training set is set as 80%. This means training set is 80%. So convert a data frame into an array structure using, so data frame is converted to an array structure using copy function. Then split function of the cross validation from SCI kit to divide the data into training set and test set. So first of all, you need to build the linear regression model using these packages: stats model, SCI kit, and OLS regression of pandas, ordinary least square regression. So ordinary least square is a method to estimate unknown coefficient and intercept for the regression equation. So stats model is a Python module that allows the user to explore and estimate statistical models. So you can use sm.ols. This will create the linear regression object with a dependent and independent variable. Then how will you fit a model? You can use fit function. You can call fit function. By default, OLS function won't calculate the intercept. So you have to use add constant to calculate the intercept. So you will be getting a value like this. Matrices will be like this. So main metric is R square value, which tells that this R square value tells how much of the variance of the dependent variable is captured by the model. So its value is between 0 to 1. So p-value tells us if the model is significant or not. So now we can see that the value of R square value is 0.25 and x3 is the most significant variable. So for any value of p less than 0.05, it is significant. These are the findings. So recreate the model with only the success field goals variable and see how the model performs. So you will get an output like this. The variable has now become less significant because the R square value is low. So this model is iterated multiple times with different combination of variables. So finding the mean squared error between the actual and predicted value. This model gives the least mean square error. So the model which is giving least minimum square will be the best model. So now our aim is to predict. So we built the model. Now we have a model. So we need to test it. So we will apply some test data to this model. Test data. So we can use predict function to the result and add constant will add the intercept. of X valid. X valid is the test data. So we will get a prediction value and print the M.Sc. So that is 35.208. So we are printing both the values. The second model has lower mean squared error as compared to the first one. So second model is best. So we will be plotting the graph, scatter plot. You will get like this. So second plot will be like this. So first of all, you have to create a linear model, then fit it, then print the intercept and the data frame. So you will get like this. To calculate the R square in SEA kit, the cross validation model is used. So the value will be like this. So if you run this one, you will get a value like this. So multiple run of cross validation takes place, and usually the multiple running value is 3. The highest value is of 11, and you can see that it is similar to the one we have built earlier. So mean squared value is calculated and we will get a value 35.208. This is defined in scikit package. So we will plot the scatter plots, actual versus the predicted value. So you will be getting like this. So generating recommendation with collaborative filtering. So collaborative filtering is the process of filtering for information or patterns using techniques like multiple agent, viewpoint, data sources, etc. It will be used in some areas like financial data, commercial data, and web applications, etc. So suppose you want to find what is the principle behind this collaborative filtering. Suppose you want to find persons who are similar to each other by looking at your taste. For example, suppose I am watching a action movie named M. And suppose another user X is also watched this movie M. Then suppose this X watches some other action movies like M, N, O. Then if I am watching this action movie M, it will display similar movies like N, O, etc. That is the principle behind collaborative filtering. So types of collaborative filtering includes user-based collaborative filtering and item-based collaborative filtering. So recommendation data, we will use a set of users who have given ratings to the movies of the choice. The following is a dictionary object contain different users in the form of keys and their values in the form of dictionary of movies, with each movie's value being rating given by a user-based collaborative filter is used finding similar users based on Euclidean distance score or Pearson correlation score. So ranking the user is based on recommending items. So finding similar users. When you have the data about what people like, you need a way to determine the similarity between users. Similarity between different users is determined by comparing each user with other user and computing a similarity score. So how will you find a similarity score? you can use a measure known as Pearson correlation, Euclidean distance, and Manhattan distance. So in the previous example of action movies, you have to calculate the similarity score between I and X. Euclidean distance score is the minimum distance between two points in space. For example, plotting the users who watched 3 movies. So create a data frame that contains these users, where these users contain some ratings also. So initially the data will be empty. And for each movie, for each I in the movie, I in movie user preference dot keys. So we are using the movie user preference keys. So for each I, we are appending the data. For I, first data, we are appending the user movie preference of the first user, Diangio, is unchanged. And the second user, Avenger, has Age of Ultron. So this is try these options except pass. So then you have to create a data frame with this data. This is the data. Here we are appending data with I. I means column number 1, row number 1. Then user preference, some value. 2 values are printed and it is appended. So this is data. Then we are using 2 columns to adding 2 columns user, Diangio and Avenger. So what will be the output of DF? So it has 3 columns. The first column user, the first user's rating, second user's rating. Using the preceding data frame, we will plot the different users by keeping Diangio as the y-axis and Avenger as the x-axis. So we are having 2 different users. So df.Diangio and df.Avenger are the arguments. So in the X label, you can use Y label like this. Plot is the object, so you can use plot.x label and plot.y label. So you can use enumerate I text. So annotate means you can type, you can use some text value associated with the graph. So what is associated? txt. txt is enumerated in the df.user. So it is plotted. So look, this one is the annotation. We are associating some text value associated to each and every pair, that is annotate. So now let's see how Jill and Toby are closer to Robert or Max. So for that we can calculate the Euclidean distance between Jill and Toby, and then the Euclidean distance between Robert and Max. So Euclidean distance between Jill and Toby is 2.95 and the Euclidean distance between Robert and Max is 1. So what does it mean? The users are far away from each other, the higher the Euclidean distance. The smaller the Euclidean distance means it is having higher similarity. So we will be dividing the Euclidean distance by 1 to get a similarity for a higher number. We will also add 1 to the denominator to avoid getting 0 division value. So 0.25 means there is less similarity. 0.5 means it is better than the previous similarity, that is between Jill and Toby. That is Robert and Max is better than this one, Jill and Toby. Create a function that calculates the similarity score based on Euclidean distance between two users, where all the movies that are watched are taken into consideration apart from the two movies. So we are using a list of movies. So a function is defined like this: def followed by function name. So this similarity distance is the function name, and these are the arguments of the function name. Arguments of function. Okay, get the list of shared name items. So we need all the list of films. So for that you have to use SI equal to MD. It is a array. So for each item present in the preference of first person, if the item in preference of second person. So first person preferred one object, and if second person is also preferred that object, then we can set the similarity equal to 1. If there is no rating in common, you can set it as 0. If length of SI equal to 0 means return 0. Otherwise, add up the squares of all the difference. And this is known as Pearson coefficient. So preference of a person 2, item, comma 2. Then we are taking the preference of second person. So all the items in person 1, if there is an item in the preference of person 2, then we will return 1 by 1 plus sum of squares. So similarity index between Sam and Toby is 0.027. That means there is no similarity between Sam and Toby. Pearson correlation score. The Euclidean distance is how far apart the users are from each other, whereas Pearson correlation takes into account the association between two people. We will use Pearson correlation to compute the similarity score between two users. How Sam and Toby are correlated to each other. Like the previous slide, we are going to create a new function, create movie user, and we will get an output like this. After that, plot a scatter plot using annotate function. We had studied it earlier. You will get a graph like this. And you have to compute a correlation coefficient between Sam and Lily. So you will get 0.37 and 0.469. What does it mean? So in order to plot the scatter plot of correlation between Sam and Julia, you can use the following code. This code, we had discussed it earlier. So you will get a plot like this. So again, computing the Pearson coefficient. So you will get 0.88 and 0.47. So Sam and Julia are very similar to each other as the correlation coefficient of 0.88 is close to 1. In the previous case, it was far away from 1. So they are not similar. Here, Sam and Julia are similar because the Pearson correlation is 0.88, which is closer to 1. So here, this is a function used to calculate the Pearson coefficient. You can just go through this code. Ranking the user. Once we have the method of computing the similarity between the users, we have to rank them based on the similarities. So first of all, you have to check the precedences, check the similarities. Scores are stored in score. Similarity scores are stored in scores, and for each preferences, sort the scores, and then reverse it. And based on this one, we can rank the user. To see the top 3%, you can use top matches, movie preference, Toby n equal to 3. N equal to 3 means you need 3 top users and their similarity index. So this is the similarity index of Jill and Toby. This one is the similarity index of William and Toby. This one is the similarity index of Sam and Toby. So recommending item. Once you know who is similar to you would like to know the movies that are recommended for you. So in order to compute a score for the movie, we can find out what the most recommended movie is. For example, suppose you got the similarity score like this. These are the users and similarities are gone. We multiply the similarity score by the movie rating of each user. We then sum up this score and then divide it by applicable similarity score. So that is weighted average based on similarity score. So we are using weighted average. And here, in the previous case, Gone Girl had good similarity score because it is having 9. Then it is followed out by Kill the Messenger. So these recommendations are used for a user uses some logic, and based on that you can write a function get recommendation. So similarity index for each preference, if there is similarity between 2 persons, then you can ignore that score. There is no similarity, then you can ignore. Otherwise, take the preferences. You can calculate the score, then take the rank, sort it, reverse it. And based on the recommendation, you will get some values. So, Gone Girl is having 6.58. That means it is highly preferred, highly recommended. So that's about collaborative filtering. Now it is based on, that's about user-based collaborative filtering. Now we will be going to item-based collaborative filtering. So in the case of user-based collaborative filtering, we will find some similarities between user, and based on the similarity, we will use a ranking. We will sort the similarity score and find a rank. Based on the rank, we will recommend. Item-based similarity finds the similarity between items. Then it is used to find new recommendation. To begin with item-based collaborative filtering, we import our dataset by putting the movies in the first layer followed by. So in this case, we are writing a new function, transform preferences. So here we need to flip the item and person. So compared to the previous collaborative filtering, user-based collaborative filtering, we are flipping the item and person like this. Here this is item person. This one is person and item. Okay, so we are flipping it. And after that you will get a number of results with flipped data like this. To find the similar movies for each of the movies, you have to calculate create a dictionary of items showing which other items are most similar. So again, you have to insert the preference matrix to be item centric. So then find the similarity measure and score. So you will be getting like this. So once you have the similarity between all the movies, we generate a recommendation for the user. After generating the similarity, you have to generate recommendation. The following table shows the movies seen by Toby under the movie column and the rating given by Toby. The movie column contains movies similar to the one seen by Toby. So the column R as prefix are the products of rating and similarity. Finally, normalize the value. So this one is the movie rating, then followed by some columns, recommendations. So based on these recommendations, kill the messenger is the most recommended one because it is having so it is using this logic. We had seen it earlier. This is the so generate recommendation for Toby using item based recommendation. So here we will get 7 is killer the messenger is having highest recommendation.